Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll implement shops and the treasure room in the game. So you can see I started a new run here and hopefully I'll make it through this shop. And after a while, you can see that I indeed played well because I could reach the shop. So if I click on this shop, you can see I transferred into this screen where I can buy cards and relics if I have the money to do so. So if I click on any of those cards, I can get the description. And similarly, if I click on any of those relics, I can buy them as well. So I won't spend any money here because I wanted to show you coupons, and unfortunately I don't have enough money to buy it right now. You can also see a cool little visual addition that this shopkeeper guy here blinks at random intervals to make the scene feel a bit more nice, more organic. So we can leave the shop without buying anything, and we can continue onwards. Now if we go to this new shop, I definitely have the money now. Okay, so coupons is offered again. And if I click on this relic and buy it, you can see that it instantly flashes. If I click on it, it says all the items in the shop are discounted by 50%. And you can see that indeed all the prices went down a bit. So I can buy some cards if I want to. Gets added to my deck. I have 11 cards now as I bought this one as a new. We can leave the shop and go to the treasure room. And it's a pretty simple room. We have this little pulsating chest here indicating that the player can click on it. And if I do click on it, a nice animation plays and we are greeted with a reward screen, which shows that we are rewarded with a new relic. And if I click on it, indeed, a relic gets added to my relic handler and I can click on it and it says at the start of combat, gain 1 mana. Awesome. So if I continue, I can go into the battle. All the relics are working as expected. So without further ado, let's get started. So I have the project open here, and you might have noticed that we didn't have an architecture overview like we usually do. The reason why is that we sort of already have the architecture cut out for us in the case of the shop and the treasure rooms. It's just that they are at the moment placeholder things and we need to fill them with content, right? And all the interactions will be between the run, which is, if you remember, the brain of the whole operation, and these new systems, the shop and the treasure room. So everything will be explained as we go, but we don't have any like big new architecture stuff. Let me show you what I'm talking about. If we press Ctrl+Shift-O to quick open a scene, we can search for shop.tscn. And you can see that we already have something for the shop, but it's just a placeholder. And we have to replace this with an actual shop, and the same goes for the treasure room. So we already have the like back and forth. We can go from the map to the shop and from the shop back to the map. We will make some changes, but they will be very slight changes like adding new signals to the event bus. And other than that, these are like very individual systems. We can just edit them as we go. So why don't we start with the shop first? Basically, we can get rid of almost everything, all of these placeholder things. We can delete the color rectangle, the VBox container, and the label. If we want to, we can keep the button, but we don't have to. We can just redo that button in a second. Okay, so now we have nothing, right? I kind of like the background though that we used for the campfire. So in order to just save time, I will just reuse that. So press Ctrl+Shift-O again, search for campfire.tscn. And you can see that we have this kind of nice looking gradient background here on its separate canvas layer. I just select the background layer node, press Ctrl+C to copy it, go to our shop scene, select the root node and press Ctrl+V to paste it. So we don't have to redo it. But again, I encourage you to use your own graphics, design your own backgrounds and so on. I just don't want to waste time with that in the video. But in order to make this shop look nicer, we do have a shopkeeper. And to keep things tidy, I decided to put everything on a separate canvas layer, just as like a good practice, so we can edit them or change the order of them if we want to in the future. So let's select the shop, the root node again, click on the plus sign, add a new canvas layer node, and we can call this something like decoration layer. And we can duplicate this by pressing Ctrl+D and do another one, and I'll call this UI layer. So this will be where all the interaction happens. And so the UI layer will be on layer 2, and the decoration layer can remain on layer 1. Right, so for the decoration layer, we can select this canvas layer node, click on the plus sign or press Ctrl A and add a texture rect node for the shopkeeper. We can double click and rename this to Shopkeeper, something like that. And we can change the texture from the empty one. And I'll be using this sprite for the shopkeeper. Right, pretty nice. So we can change the expand mode to ignore size and the stretch mode to keep aspect centered. And we can resize this guy to make him a bit bigger, go to layout and custom minimum size. Or in this case, we don't even have to set the minimum size. We can just go to transform and set the size itself. And I'll just double it so it will be 80 by 80, like so. We also want to change the anchoring. So I want the shopkeeper to be at the bottom left corner. So click on anchor presets and anchor it to the bottom left corner. And just to make sure that he doesn't like stick to the bottom left corner, we can go into move mode by pressing W and move him a bit away from the corner, maybe something like this. Perfect. So I go back to select mode by pressing Q, and we can add a couple more nodes to this decoration layer. So let's select the canvas layer again, click on the plus sign, search for animation player. Because in order to make the scene a bit more interesting, we'll make the shopkeeper blink at random intervals, so the scene looks a bit more alive. We can close the animation pane for now and rename this to something like shopkeeper animation. And we can select the decoration layer once more, click on the plus sign, press Ctrl A, and then we can search for timer. We'll add a timer to the blinking, and we can double click and rename this to blink timer. And make sure to set this to one shot. And what this does in the case of the timer, it says that if true, the timer will stop when reaching 0. So if you don't set it to one shot, then after expiring, it will restart itself. But we don't want that. We want to start it manually from code at random intervals to make it a bit more organic. We don't really have to worry about the wait time because we will set this from code. Okay. So for the shopkeeper animation and the blink timer nodes, we can select both of them by pressing and holding Ctrl or Shift in this case, clicking on them, right click and access them as scene unique names. So it's easier to reach them from code. Right. We can also do the animation because it's pretty simple. So if we select the animation player, the animation pane will open on its own. Click on the animation button, new, and create a new animation, which we'll call blink. It can be pretty short, so we can do something like 0.15 seconds, for example, and we can press and hold Ctrl and scroll with the mouse wheel to zoom in, and we can change the snap to 0.05 to make sure that we can scrub through the timeline perfectly. And to make him blink, we just kind of have to change the sprite, right? So let's click on the shopkeeper, and we have this keyframe icon or key icon next to the texture. Perfect, we can click on it. We do want to create a reset track, and we can move all the way to the end of the timeline and create another keyframe. And to make him blink, we'll just basically select the first keyframe and change the texture's value. So again, I click on the arrow, load, and from the art folder, we have a file called shopkeeperblink.png. And what this does is it makes it look like he's blinking. So if I play the animation, you can see that it kind of looks like he's blinking. And in order to make this organic, again, we'll use a timer with a random waiting time as an interval between the different blinks. So it will be random to make it feel more organic. Pretty cool. This is just a visual juicing thing, but I figured we might as well do it on the go, and we'll add the code later. Let's save this because it's always a good idea to save occasionally with Ctrl S. And now we can move on to the UI layer. Okay, so for the UI layer, let's select the canvas layer first, add a new child node or press Ctrl A. First, we'll add a label node. So we have a title. We can rename this to title, and we can enter something like shop and make sure that it's aligned to the center on both axes. And it's a bit small for my liking, so let's add a new label settings resource to it, but this is way too big. So let's go to font and change it to something like 12 maybe. Yeah, I kind of like that. So we can anchor this to the center and just roughly position it where we want it to be. We'll worry about this later when we actually have the cards and the relics here. For now, let's just press W to go into move mode and put it somewhere around here. And we can always come back to this and reposition it if we wanted to. we can go back to select mode by pressing Q and select the UI layer again. Click on the plus sign or press Ctrl A. We'll add a button to leave the shop. So search for button. For the text, we can enter something like leave, and under layout and transform, we can set the Y value to something more reasonable, like 14. Yeah, I kind of like that. I'm okay with the 40 pixels wide button, so let's anchor this to the center as well. And go into move mode by pressing W, and I will position this somewhere over the shopkeeper's head like this. Yeah. And we can rename this. Let's go back to select mode by pressing Q. We can rename this to back button, and we'll connect the press signal to our shop later on. Right, so we can move on to the most interesting part of this, where the content will be inside the shop. So let's select the UI layer once more, add a new child node or press Ctrl A, and search for a VBox container. So our main container will be a vertical box container, and we can call this something like shop content. And as a child node to this, let's another one. Click on the plus sign or press Ctrl A, and we'll have one HBox container for the cards. We can double click and rename this to cards. And again, by selecting the shop content, we can add a new child node by clicking on the plus sign and add another HBox container, this time one for the relics. Okay, pretty cool. Both of those need to be accessed inside our shop script. So let's right click on those and select access as scene unique name to make this easier. And we can sort of position this shop content container and set the different properties, but I think it makes sense when we actually have cards and relics to put inside. We don't have those scenes yet, so we can leave this as is for now, and we'll just come back to it when we actually have something to look at. But this is the basic structure we need. We'll add some stuff later on as we expand on our shop, but that's the most basic ones. So let's save the shop scene for now with Ctrl S. And we can continue by creating the stuff you can actually click on inside the shop. We'll have one interactable for buying cards and another one for buying relics. We'll start with the cards first. And to do so, let's click on our plus sign here to create a new scene. And our root node for the ShopCard scene will be a VBox container. So let's click on other node and search for VBox container. Let's zoom in a bit to see what's going on better. Double click and rename this to ShopCard. And add a child node by clicking on the plus sign or pressing Ctrl A. And we can search for the center container. So we'll have a center container. And inside that center container, we can rename this, by the way, to something like card container. And inside that, we'll instantiate a card menu UI because we already have that scene. So click on the instantiate child scene button or press Ctrl Shift A and search for card menu UI. And you can instantly see that we have a card right there. And because of the center container, this will be centered perfectly for us. Pretty cool. For the card container, we also need it in the code later, so we can right click on it and access it as a scene unique name to make it easier for us. And we can do the next child under this shop card root node. Click on the plus sign again. This time we'll add an HBox container for the price. So we can double click and rename this to price. Right click on it, make it scene unique because we need this in code as well. And under the price, we'll add two new child nodes by clicking on the plus sign. The first will be a label for the price. We can call this something like price label. For the text, we can enter 999 for now. So we'll select the price again, the HBox container, add a new child node again. This time we'll add a texture rect for the icon. We can rename this to gold icon. And we can load the texture from the art folder, this gold icon here, but this is way too big, right? So we can set it to ignore size, keep a spec centered, and under layout, we can set the minimum size to 10 by 10. Pretty cool. So the price label is something we need to change from code to, so we can right click on this and access it as a scene unique name. And for the price itself, we need to do two things. I don't really like this big distance between them. But I also don't like that they are not centered. So for the alignment, let's change it to center instead of begin. And under theme overrides and constants, we can set the separation to whatever we like. I just use 2 pixels. I think it looks a bit cleaner if they are closer to each other. Perfect. And one last thing we need is in the shop card itself. So let's select the root node again and add a last child node here. this time a button. So we'll add the button. We can set the text to something like buy. And under layout, we can set the minimum size on the Y to something like 12 to make sure that it's not too small on the Y axis. Okay, we can rename this to buy button or something. And we'll need this in code so we can also access this one as a scene unique name. So this is how it looks like. And that's how it's going to look like in the shop. So when we click on the card, let's not forget that we actually need to display the tooltip so the player can actually check what the card does before buying it, right? Under that, we'll see the price. And under that, we have a different button with which you can buy that specific card. Awesome. One last thing we can do, or something we can change, is if we select the shop card itself, we have the default separation between the elements, and I want to make this a bit more packed too. So under theme overrides and constants, I'll set the separation to 2 pixels here as well. Yeah, I kind of like that. So now if we go to layout and transform, we can see that this takes up 40 by 56 pixels. And we need to do something here, because if we go back to the shop, you know what, I'll show you in a second what I mean. So let's just save this for now with Control S. And under our scenes folder, we have our shop folder, so we can save the shop card scene there. So before actually coding this, I want to show you something. So if we go back to our shop scene, we can instantiate these shop card scenes, right, under our HBox container we have here. So let's select our cards, HBox container, click on the instantiate child scene button, and search for shopcard.tscn. So now they do appear, and I can duplicate these 2 times. Now it makes sense to take this shop content VBox container and position it somewhere else. So for now, I just change the anchoring preset to the center, go into move mode by pressing W and try to find a spot for it, like so. One thing we can do is we can change the separation between these elements because these are way too close to each other in my opinion. So let's select our cards, HBox container, go to theme overrides, constants, change the separation to something like 15. Right, it looks much nicer. And now we can move this again, maybe something like this. Yeah. So here's what we need to do. When you click on buy, I don't want these 2 elements, the remaining cards, to sort of take over the place, right? Because if I were to buy this and then delete it under this HBox container, what happens is if I delete one, is the other 2 sort of take its place and they swap to the left. And I don't want this to happen because it looks weird. So what I want to do instead, if I buy one, it just sort of disappears, right? And those 2 stay in their places. And to do this, what we'll do is we go back to our shop card scene here and say that no matter what happens to this one, we see that the size is 40 by 56. We can set the custom minimum size to this value. So it will be 40 by 56. And this way, when we delete stuff from this, the whole VBox container will still be at least 40 by 56 pixels. So it won't be deleted. What we'll do instead is just we'll delete this node, and this node. So basically the shop card will remain empty after buying the card it represents, but still it will take up that 40 by 56 pixels. So we don't have that weird jumping we just saw. Okay, so let's save this with Control S. And let's jump into scripting, right? So we'll have to attach a script to our shop card here. So let's click on attach script. We don't really need to use a template for this one. So we can uncheck this box here. Shopcard.gd is perfectly fine. Create the script. And before we start coding, we can connect the button's signal to make sure that we don't have any typos. So let's select the button, go to node, double click the pressed signal and connect it to it. On buy button pressed is perfect. And let's see how we can code this. So the code itself for this one will be pretty simple, but we actually need some new events in the event bus to make this work with our shop later on. So let's press Ctrl-Alt-O and search for events.gd, and we'll add 2 new shop related events here. We'll have one for buying relics called ShopRelic bot, and we'll have one for buying cards called ShopCard bot. So for now, that's all we need in our event bus. Let's save this with Control S, and we can actually start coding our shopcard.gd. Okay, so let's see what we need to do here. First of all, we'll provide a custom class name called ShopCard. Then we'll have a constant for our card menu UI scene so we can instantiate a new one when we need to. We'll have an export variable for the card. This ShopCard represents with a setter function provided to it as well. Then we have a bunch of already variable references, one for our cart container, one for the price label, and the button we have. We'll also have a gold cost, which is, for now in this demo, is just a random integer number between 100 and 300, but you can determine this however you like. Maybe you can have a gold cost, like a fixed gold cost assigned to all the card resources in the game, or you can have like a different range of costs, like a minimum and a maximum range for the different cards, and you can generate it randomly on a per card basis. For the sake of simplicity, I just generate a random number for this demo. Then we'll have a method called update, which takes in a run stats resource as a parameter. First of all, we'll check if we have a card container, a price, and a buy button, because remember, when we actually bought a card, then we delete all of those nodes. It means that we can't update anything in this ShopCard scene when we have no children, basically, because it means we already bought that card. But if we didn't, what we do is we set the price label's text to the gold cost, convert it to a string, and then we do two things. In that runstats resource, remember, we have access to the current amount of gold the player has. So we check if they actually have enough gold to buy this card. And if they do, then we remove all the theme color overrides from our price label, and we set the buy button's disabled property to false. However, if they don't have enough gold, it means that they cannot buy this card at the moment, right? So what we do then is the opposite. We add the theme color override to make sure that the price label is red, indicating that they don't have enough money for it, and we set the buy button's disabled property to true. So when do we use this method, and why do we need it in the first place? Well, we'll call this actually when we set the card in the first place, but let's not forget that we have a fifth relic we need to do in this video, the coupons, right? And what that relic does is it provides a discount to all of the items in the shop, similar to a discount card, I believe it's called in Slay the Spire. So what can happen is that you go into a shop and that coupons relic can be offered inside the shop. So we actually have to deal with that specific scenario. When you go into a shop, you have enough money to buy the coupons, and when you buy it, it instantly activates, meaning that all the other remaining items in the shop should be discounted. Hence, they need to be updated, right? And on top of that, we also need to update them when we buy something, right? It doesn't really matter if we have the coupons relic or not. It still matters if we buy something. Why? It can happen that I had the money to buy that new card for 200 gold, but I spent it on a different card. So now I only have 100 gold left. So in this case, I cannot buy the 200 cost card anymore. So we need to update these colors and these buttons whenever the amount of gold the player has changes too. But this scene itself doesn't really care about the circumstances. With this update method, we just provide an interface or a method which we can call from the outside, saying that, okay, you should update because something happened. Either we bought the coupons relic or we just spent money on something else. Then we also need to have the setter function when we change the export variable, our card resource. And first we do the usual. If the node is not ready in the scene tree yet, then we wait for the ready signal, change our card property to that new card we want to set it to, and then we change that card menu UI we have inside that card container, because each card has a different card menu UI representation. So what we do is we queue free or delete the existing one if there is one. Then we instantiate a new card menu UI, add it as a child to our card container, and set the card menu UI's card property to the card we want to represent with this shop card. Pretty straightforward stuff. And finally, when the buy button is pressed, we want to emit that brand new signal we just created, this ShopCard bought signal from the event bus, and we pass on the card as a parameter and the gold cost, so how much we paid for that card. And the shop itself will handle everything that's needed to be done when we buy a new card. And then to make sure that we cannot press this button again, or we can't buy the same card multiple times, just as we discussed, we delete all the children of our ShopCard root node. So we delete the card container, the price, and the button as well. So we are left with basically nothing, but that VBox container with the minimum size of 40 by 56 will still remain there. And that's all the code we really need for our ShopCard scene. So we can save this with Ctrl S. And let's go back to 2D view. And just to test it, select our ShopCard root node, go to the inspector tab and set a card. Okay, so we can test this. So let's go into characters, warrior, and set it to whichever we want to. Let's use the true strength one. Save this, and we can run the scene. So if we run the scene, you can see that this instantly updated because we have that icon and the rarity and all that stuff. But the gold is still 999. But if I click on buy, then the deletion itself also works. And if I go to the remote scene tree, you can see that this VBucks container, the root node is still there, and it has that minimum size and size of 40 by 56. Pretty cool. So if we go to our shop scene instead and check these shop cards we have here, we instantiated those, remember? So we can test the shop scene as well. Okay, so it does update, and I can click on buy, and you see that space still remains there after I buy all the cards. So why doesn't the gold update? It still says 999, right? If we go back to our ShopCard script here, you can see that we actually updated inside this update method, but we didn't call this, right? And the reason why is that we don't have the system hooked up yet. We don't have access to our run stats. One thing we could do is use a dummy run stats resource to test it, and then we can call this inside the ready function to see if it updates. Or we can just believe that this works, move on, and test it later on when we have all the logic intact. Even though the former sounds like more work, it's probably a good idea to do it so you can test it before you move on to other things. So why don't we do it here as well? So what we should do is we should go to our file system and create some testing data, right? So one thing we can do is we can create a new folder, for example, for test data. So right click on the root folder, create new folder, and let's call it test data or something like that. And under the test data folder, we can create a new resource, and we need run stats, right? So let's search for runstats.gd and say test run stats or something like that. And we can expand this folder, double click on it, and you can see that we have 70 gold, whatever these stats are here. Okay, so now we can write the testing code. We can do something like in the ready callback, we can call the update method, and we can just preload that run stats resource we created. And the easiest way to do it is to just drag and drop this inside the code editor, press and hold Control, and this will put it inside that preload statement. Pretty cool. So now if we save this and run the scene again, you see that the thing is updated and it says 116 gold, and we cannot buy it because we only have 70 inside that resource. Awesome. So this case works pretty well. And if we want to test it for the other case, we don't have to do anything, but just go back to our inspector here and say that we have 1800 gold, right? Save this, run it again. And now it's white and we can click on the buy button as well, right? So even though this might seem more work than just moving on and assuming it works, it's still better because we know for sure that this code here works perfectly fine, right? And when we're done, we can just delete this from the ready callback and we can move on to our next topic. Awesome. So we still have a problem. Let me show you what I mean. If we go back to our shop scene and run this scene by pressing F6 or clicking on that button, if I click on the cards themselves, nothing happens, so I have no way to tell what these cards do, right? So we need to fix that by providing a tooltip. And if we go back to 2D view inside our shop scene, we do have this functionality made already, right? We used it for viewing cards inside the deck or the discard pile, or even in the card reward view or scene. So what we can do is we can select our UI layer, click on the instantiate child scene button or press Ctrl+Shift+A and search for card tooltip pop-up, because we do have this scene we can reuse, right? This one. This is exactly what we want to use here. And right now we don't need it by default, so we can hide it by toggling its visibility. And make sure that we can access this as a scene unique name so it will be easy to hook up inside the shop. Right, but how do we hook that up inside the shop? Well, we have a bit of an issue here or something to think about. So let me show you what I mean. Let's save this scene by pressing Ctrl+S and go back to our ShopCard scene here. So we have an instantiated card menu UI, right? And if you remember this card menu UI scene, we open up the script for it, has a signal called tooltip requested. So it does emit that signal when we click on it. The problem is we do nothing with it, but we don't really want to do anything with it inside the shop card, right? I don't want to instantiate 3 different card tooltip pop-ups inside the shop card because there's really no reason to. We want one inside the shop itself. But the problem is that this signal is pretty far away from the shop, right? Because it's not the shop card itself which emits that signal, but the card menu UI inside the shop card. So one of the options we could do here is called bubbling up the signal. And what this means is that we take the ShopCards script, say that we define the same signal again here, card tooltip requested, and when the card menu UI emits that signal, we connect to it and we emit the signal too from the shop card. I don't really like bubbling up signals because I think it's harder to track what's going on, and it's also pretty redundant if you think about it. Why would I define the same signal twice? It does the same thing, so it makes no sense to me. But in a sense, it's a pretty clean and clear solution, but I don't really like it. Another idea is to change this whole thing, maybe refactor the card menu UI and say that instead we'll use the event bus, right? So it's not a signal declared inside the card menu UI, but a signal declared in the event bus. That works too, but that would result in a refactoring, which I don't really want to get into now. It's probably a good solution because that would mean that we only need one card tooltip pop-up inside the whole game, and then we can rely on that one to work. Maybe the problem with that is that it becomes harder to test. Let me show you what I mean. So if we have inside our run scene, let's say we have a card tooltip pop-up here, right? Just that one. And I don't need to instantiate multiple of those, because if the event bus is the one emitting the signal, then we can just connect to it inside the run, and in the whole game, this will work. So if I click on a card menu UI anywhere in the game, I will rely on that card tooltip pop-up being here to display the tooltips. But the problem is what happens if I want to test the shop itself and don't want to start a new run for it, right? So then nothing will happen if I click on that specific card menu UI because we don't have a card tooltip pop-up connected to it because it sits inside the run. Hopefully that makes sense. So that's a clean solution on its own, but it's not without its own problems. The third one, which I opted for here, is kind of different. I'm not saying that this is the best solution I selected here. That's why I wanted to tell you all about my different ideas here. I just think that it's the one that I hate the least, if that makes sense. So what I do instead is keep track of that card menu UI inside the member variable in our ShopCard script, and then I can access this from the shop and can use the default signal which we already have inside our card menu UI. It's a pretty easy solution actually. So what we do is we provide a member variable called current card UI, and this will be the card menu UI we currently have, right? And then if we scroll down inside that setter function, when we create a new card menu UI, we just need to change this to make sure that it keeps track of all the changes we have. And that's it. That's all the code we need from this class. And now we have this member variable, which we do have access to. So we can say that we want the ShopCards current card UI's tooltip requested signal. And that works. So we eliminated the bubbling by keeping track of which card menu UI is currently instantiated inside this ShopCard instance. Okay, so that's all the code we need here, but how do we hook this up inside the shop? Let's save this for now with Control S. Press Ctrl Alt O and search for shop.gd. And before we change this script, we do have some code residue here from our previous placeholder code. So let's go back to the shop scene actually, go back to 2D view and make sure that we connect our back button, this one, to the code first. So select the back button, click on node, double click the press signal and connect to it. And we don't need this one, but we still need to emit the shop exited signal. So we can just take this piece of code here and paste it right there. And we don't need this piece of code anymore. Okay, so how do we handle the tooltips? Well, we'll get into this later because we need to generate random cards, right? A random selection of cards, but we don't have any of that functionality yet. So this is just more or less a placeholder code to show you how it works. First of all, we'll provide a custom class name for the shop. Then we have two already variable references, one for our cards HBox container and one for our called tooltip popup, which we instantiated. Then inside the ready function, what we can do is we can iterate through all the shop cards, which are the children of that cards HBox container, and connect to that tooltip requested signal directly. So this is what I mean by tracking that variable. So we have our shop card, and we know that now our shop card has a member variable called current card UI, which is the card menu UI itself, which does have that tooltip requested signal, and now we can connect to it. And say we just connect to it to our called tooltip popups show tooltip method. And one thing we can also do to make sure that it's easier to use is to override our input callback and say that if we pressed escape, our UI cancel action, and the card tooltip popup is visible, we can hide the tooltip window just so we can close it with esc as well. And that's how we can sort of resolve that problem in the third solution I presented. So if we save this with Control S and run the shop scene again with F6 or clicking on that button, we do have the functionality ready to go, and it does work with escape or clicking on the same thing again, right? So that's one way to solve that problem, that the signal itself is pretty far away. I think this is better than bubbling it up, but again, it's up to personal preference. So the next thing we need to do is pretty much the same, but for buying relics. Luckily for us, it's pretty similar to what we did with the cards. So we can just go back to 2D view, switch to our shop card scene, and save a new scene by going to scene, save scene as, and we can call this ShopRelic. And it's pretty much the same thing, we just need to rename some stuff. So we'll rename ShopCard to ShopRelic. We can detach the script as we'll create a new one. We can rename the card container into Relic container, and we can actually grab the card menu UI here and delete this as we don't need it. But inside that Relic container, what we do need is to instantiate a new child scene, or press Ctrl-Shift-A and search for Relic UI, the same thing we did in the last episode and what we have for relics. And that's it basically, but we do need to be aware of something. If I select our ShopRelic here, you can see that it's taller than it needs to be because the icons are much smaller than the card menu UIs. So if we reset the custom minimum size to 0, you can see that the size changes to 40 by 42. So we can just re-input that value to make sure that it's just as big as it needs to be when we delete all the stuff. Pretty cool. That was a quick one, so we can save this and actually create the script for it, which will be pretty similar to what we did with the shop cards. So we can attach a new script. We can call this ShopRelic.gd. And we need to make sure that we connect the buy button's pressed signal to this. So select our buy button, go to node, and you can see that it says that we have this connection established, but it was only connected to the script we just replaced. So let's right click on this and disconnect it, click on it again and connect it to this new script right here. And let's see what we need to do. Okay, so first things first, we'll provide a custom class name called ShopRelic. Then in a similar fashion, we have a constant called Relic UI, so we can dynamically instantiate new Relic UIs when we change that export variable, this time not for the card resource, but for the Relic resource. Again, we have a setter function connected to this. Then we'll have a bunch of already variable references, just like we did before. And in a similar fashion, I just opted for a random gold cost between 100 and 300. Then we have the update method, which is virtually the same that we had for the cards. So again, we'll check if this shop relic was already deleted because the player bought that relic, and then we can return from this function immediately if that happens. But if it didn't, then it means we need to update our price label, and we need to check if the player has enough money to buy it. Then we delete the color override, set the disabled to false for the button. Otherwise, we set it to red and set the disabled property of the button to true. Then we have the setter function. Again, similar stuff. If the node is not ready in the scene tree yet, then we wait for the ready signal, set the relic to the new relic we want it to. Then we delete the old relic UI if there is one, then instantiate a new one, add it as a child to our relic container, and set the new relic UI's relic property to the relic we want to add. Last but not least, we emit that new signal from our event bus that a ShopRelic has been bought with two parameters, one for the relic that we bought and one for the gold cost. Then we just take the relic container, the price, and the buy button and delete all of those. Right. So the code is very similar to what we had before, but you might have noticed that we have a slight difference. Let's save this with Ctrl S. And the difference is basically related to the tooltip thing we just dealt with for the cards. We don't have tooltip related code here yet. But before we jump into the tooltips, let's just test this, right? So let's go back to 2D view, select the ShopRelic, go to the inspector tab and override this relic export variable with a relic of our own. For example, the mana potion, save the scene, run the scene by clicking on this button or pressing F6. Okay, the gold is not updated again either, but we do have the icon. I can click on buy and it disappears. Awesome. So again, if we want to test the gold as well, we can do the same ready signal thing we did before. So we can say something like update, preload, and we can preload our test run stats resource. And if we run the scene again, okay, we do have our relic gold cost updated to 266, and it's wide because if you remember, we set this resource to 800 gold for our last test. But if we double click on it and change it to something like 50 and run the scene again, it will become red and we cannot buy it anymore. Awesome. Just to make sure everything works, we can delete this code from here. So what about the tooltips? We talked about those three possibilities, right? Using the event bus, bubbling up the signal, or the third one, which we opted for in the case of the cards, which is keeping track of that card menu UI instance. See, for the relics, it's a bit different because if we go to our relic UI script from the last video, how did we implement tooltips for the relics? You can see that we have our GUI input callback, and you see that we do use the event bus for this. So when we click on that one, we emit that relic tooltip requested signal from the event bus and pass the relic resource as a parameter. And that means that we do emit the signal from here too. So when I run this ShopRelic scene, if I click on this event bus signal is emitted, but nothing happens because no one is connected to that signal. But the interesting thing is, for the run scene, if we go back to 2D view, we have our relic tooltip scene instantiated here, which does connect to that signal. So we actually ran into the problem I was mentioning. It works perfectly fine, but we cannot test it in isolation. So we cannot test it from the shop. If we go to our shop here and instantiate some ShopRelic scenes under our relics HBox container, let's just do that. So let's use ShopRelic and let's duplicate it twice. Again, for this HBox container, we can set a bigger separation so it looks nicer, something like 15. And we do have our thing ready to go here. I kind of like how it looks like and where it is. Maybe we can go into move mode by pressing W and move it a bit down, like so. And we can finally actually position the title because we do have the data here. So select the title node. I'm still in move mode. And maybe just do something like this. Go back to select mode by pressing Q. Okay, so now we have our shop basically ready to test, right? So if I run this shop scene, we know that it does work for cards because we instantiated our own card tooltip pop-up here. But for relics, it still doesn't work because we emit the signal from the event bus, but the problem is that the relic tooltip pop-up, which shows the description for the relics, is instantiated inside the run. So we cannot test it on its own, even though it works. So let me show you that it works. Just to make things a bit quicker, I go into the characters folder and change the warrior's axe attack and make it deal 60 damage instead of 6, so it will make a breeze to run through the whole game. So let's run the game instead the open scene now, and we start a new run, right? And it's perfect because we have a shop right after the first fight. So if I go into that fight, kill that enemy, and if I kill that enemy, I take some gold here, and if I go into the shop, we have our brand new shop here, right? So I can click on the cards, and because we have that card tooltip pop-up inside that shop scene, we set it up and it works perfectly. But here, we do get the relic description if I click on those. That's because it was set up correctly. So if I click on the Relic UI, it emits the event bus signal, and the run itself is connected to that signal. So now I have the Relic tooltip and the connection is set up properly because I'm inside the run. I entered this shop from the run scene, right? So it does work, but it makes it harder to test. So this was a super useful introduction to like how different solutions have different ups and downs. So for the card, we made it so it's testable on its own. But for the Relic UI, we actually didn't have to do anything related to tooltips, which is pretty neat because it just kind of works out of the box if we include the Relic UI anywhere in the game. The downside is that we can only test it if we enter our run scene first. So I can buy everything and the shop goes empty. I can leave the shop and we can move on. So what's left to do is that we actually populate the shop with not dummy data, and we make sure that it gets subtracted from the gold, and when I click on buy, the card gets added to my deck and the relic gets added to my relic handler. So basically the functionality for the shop. And that's what we'll do next. So the next thing we need to do is to give the shop the functionality it needs. So let's press Ctrl+O and search for shop.gd. Okay, so this will be pretty much the hardest thing we need to do in this video, and it's not that complicated either, so I think you can follow along pretty easily. First thing we do is we set up two constants, one for the shop card and one for the ShopRelic scenes, so we can instantiate them dynamically. Then we have a couple of export variables. 3 of those are dependencies which we'll inject from the run scene: the character stats, the run stats, and the relic handler. We need all of those for different reasons. We need the run stats for the current gold, we need the character stats for some checking stuff, and we also need the relic handler so we can add the new relic when the player buys one. However, we have a fourth export variable called ShopRelics, which is an array of relic resources. Why do we need this? Well, because in Slay the Spire, there are a distinction between relics you can get from bosses or treasures and relics you can buy in shops. Some relics can be both, so they can be received as like a treasure reward and also can be bought in shops, but some of them are shop exclusive, for example. So here I provided a way to do this by saying that the designers explicitly have to list all the relics in an array which can be displayed inside the shop. So that's what we'll do. Then we also have a new onReady variable reference to our relics container besides the card one, so we can populate that with randomly picked relics from that array we just talked about. We'll also change the ready callback, but I'll come back to this in the end when we're finished with all the new stuff. So this populate shop method is the one we'll call inside the run scene when we want to transition into a shop, right? So this will do two things: generate our possible shop cards and generate our possible shop relics for that specific store visit. So let's implement those two methods next. We have the generate shop cards one first. What we do is we create a shop card array, which will be an array of cards, right? This will be the final one where we have our 3 available cards in the shop. And we start from the available cards. That's why we need the character stats injected, because we take the draftable cards array and duplicate it, right? So we have the whole range of cards we can choose from. Then we shuffle that array and use this slice method to take a slice of 3 cards from that array, right? Because, I don't know, a character can have 90 cards. So what we do is we take all those 100 cards, shuffle them around, and take the first 3 of those. And we store that in the shop card array. Then we can iterate through that array of card resources, create a new shop card instance for each of those, add it to our cards HBox container, set the card property, connect to the tooltip requested signal of that card menu UI so the player can view the tooltip, and call the update method with the run stats resource to make sure that we update the gold, not just the icon, and it will be white or red based on whether the player has the money for that card or not. And we virtually do the same for the ShopRelics, but instead of relying on outside source like the draftable cards from the character stats resource. Here we have our own, right? We have our export variable called ShopRelics, which we fill by hand as designers, and we filter through them. And the way of filtering is pretty simple. First, we call that can appear as reward, right? Because if you remember, there are character-specific relics, for example, and if I play the warrior, wizard relics cannot appear for me at the shop, right? Then we have another Boolean variable or a flag, which checks if we already have that relic or not. So we call the relic handler's hasRelic method and pass that ID. We can only have relics offered in the shop, which can appear to us, and we don't already have it, right? So that's the logic inside that filtering. And after that filtering, what we can do is we can shuffle all the remaining relics. Again, take a slice. If we have more than 3, we only need the first 3 of those, and do the same thing we did before. So iterate through all the relics, create a new ShopRelic instance, and set it up and update it according to our current code for our run. Pretty straightforward, right? And we also have some helper methods which we'll use. One of those is called update items, and what it does is it loops through all the shop cards we currently have and all the shop relics we currently have and call the update method on each of them. Why do we need this? Well, if we buy one of those items available to us, it means that our goal will change, right? So after we bought something, we need to update all the other remaining items to make sure that they become red if we don't have enough money to buy them, for example. And we'll have 2 callback methods at the very bottom, which we are not connected to yet, but if you remember, I said that we need to change the ready callback too. So the 2 callbacks we connect to are from the event bus, the 2 new signals we have, ShopCard bought and ShopRelic bought. So what do we do inside the shop when we bought a ShopCard? Pretty straightforward things. Well, first of all, we take the character stats, grab the deck, and add the newly bought card to the character's current deck. Pretty simple, right? Then we take the run stats gold property and subtract the gold cost we paid for that card from it. And then after we're finished with both of those actions, then we call this update items we just created to make sure that all the other items are up to date with their labels and button states, right? And when we buy a relic, the other callback pretty similar, but instead of adding it to the deck, we call the relic handler's add relic method, pass the relic we want to add, again subtract from the gold, and again we can update the items we still have inside the shop to refresh accordingly. That's all we really need. It's 86 lines, so it's not that bad, but we still need to change our ready callback because if you remember, I said that this is just placeholder code we have for now. So what do we need to do inside our ready callback instead? Fortunately for us, that's pretty straightforward too. So what we do is we iterate through all the shop cards and shop relics we have as placeholders when we enter the shop. And we can queue free all of those because, again, these are just placeholders. We needed to test the whole scene. And after we deleted those, we can connect to the event bus's signals we need to take care of, the ShopCard bought signal and the ShopRelic bought signal as well. And that's pretty much it. So let's save our shop script with Control S. And we do have a lot of things here. We basically prepared the shop to take care of all the logic we need, but we still need to hook this up, you guessed it, inside the run to make sure it works. Because if you remember, we have outside dependencies, right? And we don't really call that populate shop method either inside the ready. So we need to kick things off inside the run scene when we actually transition from the map to the shop. So that's what we'll do next. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So let's press Ctrl+O and search for run.gd. And if you remember, we have this callback method called onMapExited. And this is where we decide what happens when we enter the different room types. And for now, in the case of the shop scene, the only thing we do is call the change view method to the shop scene, and that no longer does it anymore. The reason why is that we need to inject a couple of dependencies, we need to call that populate shop method and so on. So we need a custom callback in this case, or a custom method. So we'll do just that. And this method will be called onShopEntered, and it's pretty simple. We still change the view to the shop scene, but we actually store that reference to our new shop scene we instantiate here, and then inject all of those dependencies we talked about when we scripted the shop. We have the character stats, we have the run stats, and we have the relic handler. And when we're finished with all of those things, we can populate the shop to make sure that it has actually random cards and random relics available for us. And what we also shouldn't forget to do is to actually grab this method name here, and instead of changing the view to the shop scene in the case of a shop room type, we can call this brand new method we just created. And that's it. If we save this and start a new run, if we are able to go all the way to a shop, for example, this one, maybe I can accumulate some money. So I do have some money, not much, but if I go into a shop, everything works properly. I should be able to see the relics and the cards. And it kind of works. I can see the cards here. I have 2 of those, which I don't have enough money for. I can see the descriptions to all of those. And I can technically click on buy. And you see 2 things happened here. One of them is that the card gets added to my deck, and indeed it happens as the 11th card. But I don't know if you noticed, but some minor thing also happened. This whole relic bar here moved a bit to the left. Why is that? Well, because we don't have minimum size for this gold bar or this gold container we have here, and it became 1 digit instead of 3, so it shrank basically. And I don't really like how the relic bar keeps jumping around based on how much gold we have. So that's one thing we can fix real quick, but the card buying itself is working. But see, we have another problem. We don't see any relics up here. But what's going on? I can leave the shop, I can continue forward, everything works fine. Let's tackle this issue separately. So the easier one to fix is the jumping around in the top bar. So let's go to the run scene, go back to 2D view, and if we select Health UI here, go to layout, you can see that we have no custom minimum size. So again, based on the amount of HP we have, it can happen that it jumps around. So we can check the transform. Okay, it's 30 pixels on the x-axis. So maybe we can make it something like 35 to make sure that we can have double-digit HP. And for the gold UI, I kind of like how big it is with 4 digits. So if we again go to the transform, we can see that it's 30 pixels. Then we can set the minimum size to 30 pixels. And if I have 1 digit gold, it will still be at least 30 pixels. So this relic handler scene won't jump around. Okay, so that should be fixed now. We can save this with Control S. So what about the relics? Well, I forgot to do one thing. If you go back to the shop, and go back to the script of the shop, how do we generate the possible ShopRelics? Let's go to that method. Well, we take the ShopRelics and filter through them. Okay, so what are ShopRelics? If we press and hold Control and click on it, you can see that it's an export variable with all the available relics we can take. That's fine and dandy, but I actually forgot to set any relics. So the problem is that if I click on the shop node, back in 2D view, you can see that the ShopRelics array is empty. Size 0. So we do need to assign some available ShopRelics, otherwise we won't have any offered to us. Well, at least the good news is that we tested it unintentionally if it works with 0 relics, and it does work, it just doesn't offer anything. Say that we can have 4 ShopRelics for now. If we collapse the characters folder and expand our relics folder, we cannot buy the healing potion, right? Because it's a starter relic, but we can buy all the other ones. So we have coupons, explosive barrel, mana potion, and reinforced armor. So now we have some relics we can offer. And if we start a new run again, we should be able to see and test the relics as well. Okay, so now I have 3 fights before a shop, but we'll see. Okay, so I managed to pick up 244 gold, and if I go to the shop, indeed I have my coupons offered to me. Although we have an invisible one, it's the coupons because we didn't set an icon for this one yet, but it still works. So we can have the explosive barrel, we can have coupons, which does nothing yet. And we could have reinforced armor, but we don't have the gold for this. We already tested how cards work, but we can test it with relics too. So if I click on buy here, you can see that all the other items update accordingly because I only have 11 gold left. And the relic gets added to my relic handler up there, but I can see what it does. And if I leave this shop and go to the next battle, you can see that the explosive barrel does its thing as it dealt 2 damage to all the different enemies. Awesome. Now, to have a bit of a breather, let's add some visual polish by making this guy blink. If you remember, we do have the things set up because we have an animation, we have a timer, and all of those are scene unique names, so we can have access to them inside the shop script. So let's open up the shop script. And the first thing we do is we grab those two already variable references so we can use the animation player and the timer node as well. Then inside our ready function, after we did all this logic related preparation stuff, we can have some extra lines of code. One for setting the blink timer up randomly, and we are yet to implement this method. And then we can connect to the timeout signal of the timer, so when it expires, to another callback method which we have to implement, but don't worry, both of those are pretty simple. So for the first one, setting up the blink timer is basically just 2 lines of code. We set the timer's wait time property to a random floating point value between 1 and 5 seconds, and then we start the timer, so it takes down to 0. And then when the timer actually times out, we need to implement the callback method. So here what we do is we play the Shopkeeper animation node's blink animation, and then we set the timer up again, so we again will have random amount of time between 1 and 5 seconds, and then it starts over again, and those two methods keep calling each other when the timer times out. And this way we provided this like organic feel where the time elapsed between the different blinks will be random between 1 and 5 seconds. So that's all we need. If we save this and run the shop scene, you can see that the guy after some time blinks and again, and he will keep blinking in different intervals. Sometimes there are less time between the two blinks, sometimes there's more, and it feels a bit more organic this way. It's a nice little touch, I think. So I like to sometimes tackle these little visual interactions as well, not just heavy, system heavy work, you know. Okay, pretty cool. That's all for the visual polish, but feel free to experiment with whatever you like for your game. The next bit we can tackle is creating that coupons relic, which gives a 50% discount for all the items in the shop. And it sounds like a pretty complicated thing, and we already have our system intact. So how can we do this without it being too complicated or too embedded inside that shop system we already created? Well, the answer is we already have the tools to do so. So this is why I saved this to last, because I wanted to show you how easy it is to reuse all the different bits and pieces we made for this game. So let's go back to 2D view inside the shop scene, and what we'll use is our modifier system actually. So what we can do is we can collapse all of these to tidy the scene tree up a bit. Select the shop root node and click on the instantiate child scene button or press Ctrl+Shift+A and search for modifier handler. So we'll add a modifier handler node, and as a child to this node instantiate a child scene again, and this time a modifier. So this will be the shop cost modifier. So let's rename this to shop cost modifier and change the export variable type. This is super important, so you shouldn't forget this, to shop cost, which is an enum. If you remember, we declared inside that modifier.gd script. So this will be a shop cost kind of modifier, and we can save the shop scene with Ctrl+S. Okay, so what we'll do is when we enter a shop and the player possesses the coupons relic, we'll just add a negative 0.5 modifier to this shop cost, and we need to make sure that the shop does apply or takes that modifier into consideration when calculating the prices for these things. So let's go back to the shop script and accommodate to those changes. It's only a few lines of code, I promise. The first change we need to make is we need to make sure that we have access to our modifier handler, so we just grab it as an already variable reference. The question is, where do we apply this? Well, first of all, when we generate the ShopCards and the ShopRelics, right? So let's go to our generate ShopCards method here. And when we connected that tooltip requested signal, and before we actually updated, so right here, what we can do is we can say that the gold cost should be equal to the current gold cost, but we get the updated version of this. So this is a method we are yet to implement, but basically this method will be the one which applies that modifier value, right? So then we can call the update method to make sure that the updated gold cost is the one we show to the player. And you guessed it, we have to do the same when we generate ShopRelics. So if we scroll down a bit, you can see that for ShopRelics, we do the same. We set the relic. And before we call the update, we can do the same thing, set the gold cost for the new ShopRelic to be the updated one, which again, we are yet to implement, but we'll do it in a second. So the only thing that is remained for us to do is to actually implement that new method. So maybe under the update items, we can do something like this. So the get updated shop cost method will take the original cost as a parameter, it's an integer value, and we take the modifier handler and call the get modified value method, pass the original cost, and say that we are interested about the shop cost type of modifiers we currently have. And that's it. It was like 5 lines of code, right? So let's save this with Control S, and we can actually create the relic next. But in order to do so, we'll have to create a new event in the event bus, and I'll explain why in a second. First, let's just press Ctrl-Alt-O and search for events.gd. And this new event will be called shop entered, and we can pass the shop as a parameter to this signal. Why do we need this? Well, because this relic, the coupons relic, will be neither a start of combat, start of turn, end of combat, or end of turn relic, right? It will be an event-based one. So when do we want this coupons relic to do its thing? Well, we want to do it when we enter a shop, right? So we enter the shop, the relic itself, the coupons relic, will add that modifier value to the shop's modifier, and then we'll see all the different updated costs, right? Pretty straightforward. But in order to do so, we need to have an event which occurs when we actually enter the shop, right? But just because we have that event, it doesn't mean we emitted it anywhere. So we also need to open the run script. So let's press Ctrl-O, search for run.gd. And here we have our new callback method called onShopEntered. And we need to emit that signal here. It doesn't really matter where you put it. What matters is that it's somewhere before we populate the shop. Why? Well, because if we emit it sooner, for example here, then it means that the coupons relic can add the modifier before we start populating the shop. So the modifier will be already present when we generate the cards and the relics that shop has to offer. So it's really up to you where you emit this signal. It has to be somewhere between changing the view and grabbing that reference and populating the shop. It probably makes sense to emit it as soon as we enter the shop, but it doesn't really matter if we inject the dependencies first. I'll just leave it as is. Again, what's important is that it's before the populate shop call. So that's all the setup we need. But if we take a look at the file system, for the coupons, we don't even have the code yet. It has the default relic.gd, no icons or anything. So we cannot really test it until we actually have the code, the logic, right? So let's do the code for the coupons relic next. Right click on the relics folder, create a new script, and let's call it coupons.gd and use the relic template we have here. Click on create, and while we're at it, it's just the default one, but I have the relic resource open here, so just not to forget, we actually have to replace this script, right? It's super important, right? We replaced it, so now we can set the icon to a correct one, and we have coupons.png inside that art folder, right? The resource is basically ready to go, but we do need to code the logic. So if I double click on coupons.gd, you can see that we only have the template stuff here, right? Okay, so just to make it easier, I deleted everything. The first thing we'll need here is a bit unusual, but we do have to have a class name for the coupons relic. And I'll come back to that why we need this when we actually use it. For now, let's just bear with me, okay? So we do need the class name for it. Then we can have an export variable, again, to make it easier to tweak the value. Here I used export range. It's a percentage, so it's an integer between 1 and 100, and the default discount is 50. Then we also need a reference to the Relic UI, to our owner, to make sure that we have access to it when we want to flash it. And here, for an event-based relic, we usually need the initialize relic method, which is called once when we acquire the relic. So what we do here is 2 things. First, we store the relic UI as our owner to make sure that we can flash it when we connect to an event. And we also have the event connection itself to our event bus. So we say that when this new shop entered signal is emitted from the event bus, we connect to it and call our add shop modifier method. The reason we have this error message is because we are yet to implement that method. Then, because this is an event-based one, we also have to call the deactivate relic method, which is called once when the relic is being deleted or replaced. So when we actually lose this relic for whatever reason, either we close the game or we swap it to a different relic or whatever happens, but when we do get rid of our coupons relic, we need to disconnect from that signal, right? So it no longer applies any modification to the price whatsoever. And last but not least, we have to implement this add shop modifier method when we enter a new shop. It's pretty straightforward. It's something we already did a couple of times when we use modifiers. First of all, we can flash the relic. So this is why we needed to store this. It's because we wouldn't have access to it anymore. An alternative to using this member variable would be to bind a second parameter when we connect to that signal. And you know what? That's a bit cleaner. So let me modify this code to show you what I mean. So instead of storing it when we initialize, we can get rid of this variable, get rid of this one. And we can say that this add shop modifier has two parameters. One is the shop and another one would be the owner, which is a Relic UI. And we can say that to this add shop modifier, we bind this owner we have as a parameter, as a second parameter. This one, right? We pass this down to the callback method, and instead of saying relic UI.flash, we can say owner.flash. Maybe this is a bit cleaner. If you understand how bind works, we can get rid of a couple of lines of code. And here we have the usual modifier stuff. So first of all, we'll grab the shop's modifier handler and we'll get the shop cost modifier. If for whatever reason we don't have one, we throw an error message because all the shops should have a shop cost modifier, so we can use this relic. If we do have that modifier, then we grab the value connected to our coupons relic, right? Because if we already have one, then we don't need to apply a new discount. In theory, this couldn't happen, by the way, that we already have one, because we can only have one piece of one relic, right? We can stack relics by default, but this is just a safety check, basically, to see if we already have that modifier value. But if we don't, which is more likely, right? Then we create a new modifier value. We identify it by the relic's name, the coupons. It will be a percentage-based one. And we set the percent value of it to our discount divided by 100 as a floating point value to make sure that we get a float, multiplied by -1 to change the sign. It's basically because in order to get the discount, you have to apply a negative modifier, right? To decrease the value of the gold. But I thought that for the export variable, from a designer's perspective, it makes no sense to say that, okay, the discount is -0.5. It looks a bit abstract to me. So maybe a designer who's not a programmer just want to tweak the values. It's much more intuitive to understand that, okay, this discount percentage is 50, right? 50% cheaper. So we do those offset calculations as programmers to make our lives easier with the export variable. And then when we have the percent value set and we have that modifier value, we just add it to the shop cost modifier to make sure that it's applied. And that's it. We have that relic, which seemed to be super complicated, but with our system set up for the relics and the modifiers, it's actually not that bad. So we can save this with Control S. And probably the easiest way to test this is to apply it as the starting relic to the warrior, right? So let's search for the warrior's resource. Then we can search for coupons and apply it as the starting relic to our warrior. And now if we start a new run, we do have the coupons as our starting relic. It says all items in the shop are discounted by 50%. And if I go to a battle, kill this crab enemy, pick up the gold, and go to the shop, you can see that it's applied. It flashes, first of all. And if you remember, the cost for all these stuff was like uniformly between 100 and 300. But we do have less than 100, right? So it means that it's probably applied. If we go to our remote scene tree here, in the current view, we have the shop. And the shop's modifier handler has a runtime node here. And the negative 0.5% modifier is indeed applied. So if I go back, I can buy the relics or whatever I want to. And you can see that it only cost me that much gold. So everything's working fine, right? Well, not exactly. We do have a problem, but it's not that visible just yet. So if we go back to our warriors here and set the healing potion back as a starting relic, I'll show you what's the problem in a second. So let's change the starting gold to something else, okay? Because 70 is not that much. So let's go to run stats and change the starting gold to something like 700. So we for sure will have the money to buy our coupons relic, right? So we start at 700. Again, go to a battle, kill our crab enemy. Go to a shop. Ah, perfect. So we have the coupons relic offered to us as a shop relic. And what happens is when I buy it, okay, it subtracts the money, but we do have a problem, right? Because at least in Slay the Spire, and I think it makes absolutely perfect sense, if I buy this one, it should immediately apply that discount to all the other items which are still in the shop, but it doesn't. If you want a similar relic in your game and you want it to work it like this, then we need to fix this, right? Because it just doesn't look right. So in this case, I want it to work like this. So let's see what we can do in the shop to make sure that if we do buy the coupons, then it immediately applies. And if you remember in coupons.gd, I said that we need this class name and I'll explain why. Well, that's why. So let's see how we can use this. Okay, so how do we fix this? Let's press Ctrl+O and go back to the shop.gd file. So it's a pretty easy fix actually, but we need an extra method for this. So what we'll do is we create a pretty similar method to this update items, but we don't just update the items in this one, but also update the gold cost. Okay, so we call this get updated shop cost method we have to make sure that we take the modifier into consideration when calculating the new price. Okay, but just having this method in itself does nothing. We need a place to call this, right? So how do we sort of get notified that we bought a relic and this was the coupons relic? So we do have a callback method called onShopRelicBought, right? And what we do is we add the new relic, subtract the gold, and update the items. Well, that's perfectly fine, but we can do another check here. So what we do is we ask if that relic is a coupons relic instance. So this is why we need the class name, because this is a simple and elegant way to check if we have that specific coupons relic or not. We could use the ID, but then again, if we change the ID for whatever reason, then we need to change this code. And the class name is much less error prone, I think, and it looks pretty cool as like a piece of code. It's pretty self-explanatory. So what we do is if it is a coupons relic, then we grab this relic as a coupons relic and we call that add shop modifier method. And after the shop modifier is added, we have to update the item costs to accommodate those changes. See, the problem is to make the code a bit cleaner for the coupons relic, I said that we need that relic UI owner as a second parameter, right? And it says that this parameter expects 2 arguments, but I only provide 1. So the problem is we can't really get the relic UI connected to this relic because we only have access to the relic itself, which is the resource, but not the relic UI. So how do we fix this? As I see it now, we have 2 options because we can't really get the relic UI from this piece of code. We don't have access to it. So we either extend the relic handler so we can query the relic handler, so we get back a relic UI based on the relic we want to have, but I don't really see the point of doing that, exposing that as a public thing. I think it's just not reasonable to do so in this case. Another thing we can do is we can say that, okay, we don't really want to flash the relic in this case. It instantly applies. Why would we want to flash it? If we opt for that solution, then we can say that this add shop modifier method, if I press and hold Control and click on it, we can see that that second parameter defaults to null. And then we can provide an if check and say that if we do have an owner, then we flash it. If we don't, then we don't flash it. But then again, we did this in the first place in order to make the code easier to read or cleaner. And I don't think it helps that much. So if we end up with something like this, an extra check, an optional parameter, I think it just makes the code worse than using the original solution we had. So instead, I think what we should do is to keep this as is and revert to the other solution we had because it's much easier. So instead of having an owner here, we can say relic UI.flash. We can remove this bind from here and say relic UI equals owner. And last but not least, we have this relic UI member variable declared here, like so. So again, I just wanted to show you how development looks like sometimes. It might seem like a good idea to not do this and use bind instead, but we arrived at a problem where for this specific use case, if we wanted to flash it, it becomes much more difficult. But if we stay with this solution, initialize relic will be called when this line of code executes, right? If we add it, it will be initialized. So we know that by the time we arrive here, it will definitely have that member variable set because the initialize relic does it here. So when we call the add shop modifier from the outside, in this specific case, it can flash the relic still. Hope that you find this little detour useful and see how the different solutions affect the code, and often these decisions you make when writing code cascade, especially later on when you have to expand on systems. So let's save coupons.gd and shop.gd as well. This error message should disappear. So when we buy a relic, we check if it is a coupons relic, and if it is, we call this add shop modifier with ourselves as a parameter and update the item costs immediately. Again, this is just a really similar method to the update items. The only difference is that for these ones, we only call the update method on the ShopCard and ShopRelics. And we kind of do the same for the item costs, but we also update their cost based on the modifier we have. One small little optimization we can do is when we call update item costs, we don't really have to call update items again, right? Because this would update them twice, and we do it in the update item costs anyway. So we could do something like else and do this for every relic that is not a coupons relic. Maybe it's cleaner this way. I don't really mind having those extra, like you don't really have to worry about performance until you see actual performance hits for your game. But it might be a good idea to use this with an else just to make sure that we don't do extra calculations. Right, so we can save this and test it again. So if we start a new run, we should have the 700 starting gold, win a battle real quick. And if we're lucky, coupons will be offered in the shop, and it is. So now what happens if I click on buy? The relic flashes, the gold gets subtracted, and indeed I do have the updated prices now, so I can buy basically everything, almost everything. Pretty cool, right? So that's all we really need for the shop and the coupons relic. Now we can move on to a much lighter topic, creating the treasure room. So the last thing that's left to do in this video is to do another room or another room type we can go to from the map. And this room is the treasure room. Fortunately for us, it will be much simpler compared to the shop we just did. So let's go back to 2D view, and just as a quick reminder, press Ctrl+Shift-O and quick open BattleReward.tscn. If you remember, that's the scene or the view we see when we win a battle, right? Here we can have our gold reward, or we can have a card reward, which we can choose from. And we'll use pretty much the same for the treasure, but instead of this dialog box here, we'll have a treasure chest, which the player can click on to open the treasure they have. But what happens after they open the chest? Well, we basically have to reward the relic to them. So it's pretty much the same as this one, and we can cheat the whole thing basically by just doing the treasure chests in a separate scene, and after the animation plays that we open the chest, we can go back to a regular battle reward screen, but instead of offering gold or cards, we just offer a relic, which is randomly chosen. But in order to support this functionality, we have to change the battle reward scene itself first. So we don't just have these two types of rewards like we currently have, the gold and the card, but we also need to support a third type for relics, right? So let's open the script for the battle reward. And let's see what we need to change here. Extending this functionality is not that difficult either. So currently the BattleReward has two external dependencies, one for the run stats, so we can change the gold, and one for the character stats, so we can change the deck. But we need a third dependency from the outside, namely our relic handler, so we can add a new relic to the current relic pool of the player, right? And if we scroll down, we have two pseudo public methods here we can use to dynamically add rewards to our BattleReward screen. We have one for adding a gold reward, and we have one for adding a card reward, right? And they both instantiate the reward button and set up the different properties and connect to a signal when we press that button when we take the reward. So we have to do something similar but for relics, and this will be a new method here. So after our add card reward, we can create a new method called add relic reward, which takes in a relic resource as a parameter, instantiates the same reward button, sets the icon and the text based on the relic's properties, and then we connect to a callback function called onRelicRewardTaken, which we are yet to implement. And with that call deferred, we add that child to our rewards node, just like we do with the other ones. So the only thing that's left to do, so the BattleReward can support taking relics, is to actually implement that callback method, right? This onRelicRewardTaken. So after our onCardRewardTaken method, we'll create a new one called onRelicRewardTaken. And what we do here is we check if we both have a valid relic and a valid relic handler dependency given. If any of those are missing, then we can't add this relic, right? But if we do have both of those, then we can just call the relic handlers add relic method with that relic resource as a parameter. And we're good to go. So when we click on the button, this method will be called and we can obtain that new relic. So that's all the setup we need from the BattleRewards side. We can save this script with Ctrl S and we can go back to 2D view. And the next logical step is to create that treasure scene itself, right? So we already have like a placeholder for that scene too. So let's just press Ctrl+Shift+O to quick open a scene and search for treasure.tscn. And right here you can see what we already have, and we pretty much don't need any of this. So we can just select everything with pressing and holding Shift and clicking on the last button, press delete to delete all of those nodes. And we can get rid of everything except for the treasure root node. But we also don't have to do everything from scratch, because if we go back to our BattleReward, we can basically use the background. For example, we want the same background between the two scenes. So we can just select the background and the background dimmer nodes, press Ctrl+C to copy them, select the treasure root, the root node in the other scene, and Ctrl+V to paste them, right? If you can, always use the lazy solution. It saves you time. So the next thing we need is a label, and we already had that, so maybe I shouldn't have deleted it, but it doesn't really matter. We can just go back to BattleRewards, copy the label node 2, and paste it under our treasure as well. We can change the anchor preset of this and anchor it to the center of the screen. Go into move mode by pressing W and maybe move it a bit up. And change the text from rewards to treasure or something like that. Awesome. And now for the interesting part, we can go back to the select mode by pressing Q. And then we can add the treasure chest. So let's select our root node again, click on the plus sign or press Ctrl+A to add a new child node and search for texture rect. We can double click and rename this to treasure chest or something. Anchor this to the center of the screen as well. And for the texture, we can load the chest image from the art folder like so. And I kind of like the default size of this, so I'll just keep everything as is. Go into move mode by pressing W, click and drag this downwards while holding Shift to only move on the Y-axis. And something like this looks nice, I think. Okay, so let's go back to selection mode by pressing Q. Maybe we can change the stretch mode from scale to keep aspect center to make sure that it's actually with the right aspect ratio. It doesn't change anything in this case, but just to make sure. And we can add 2 more child nodes to this treasure chest. So click on the plus sign again or press Ctrl+A. First, we'll add an animation player. So we have some juicy animations playing. For now, we can just resize this dock to make sure we see our scene here. and select the treasure chest again, click on the plus sign again to add a new child node, and we'll add some particles with the GPU particles 2D node as well. Okay, let's create the particles next. So we can save the scene by pressing Ctrl S. And I use some like pretty random values here. Particles are pretty complex and you can create really awesome stuff with them. Feel free to experiment on your own and tweak this to your liking. I just kind of want to give you an example. So when you open a chest, a bunch of coins like spawn and shoot out from the chest to make it look a bit more interesting. Okay, so first of all, let's bump up the amount of particles emitted to something like, I don't know, 25 maybe. For the process material, we'll create a new particle process material where we can tweak all the settings. You can see that just by adding this, we already have a bunch of white squares falling down. Let's change that by going to the texture property and loading our coin instead of those white squares. Now we have a bunch of coins spawning. For the particle node itself, we don't have to change that much, but let's expand the time group and bump up the lifetime a bit, so something like 1.5. You can see that the coins indeed live longer as they fall. We set this one-shot property on, so it's not continuous, it only emits in bursts, right? And we set the explosiveness and bump it all the way up to 0.9, for example. And just by changing this, if we check emitting, you can see that the explosiveness changes how fast we emit those or how close those 25 particles are to each other. It's not really random yet, so you can see that these are 25 coins, but we'll change that in a second. So what we really need to change is the process material itself. We have a lot of settings here. The first thing we want to do is to go to spawn and velocity. So here we have everything related to the spawn velocity of the particles. One thing we really want to do is to change the direction. So we don't want to spawn towards the right or move towards the right when the particles spawn. We want to move up. So let's change that vector from going left to right to going from the bottom upwards by using this -1. And we can change the initial velocity. So you can use whatever way you like. I'll change it to be random between 80 and 100. So if we emit the particles now, you can see that it already looks a lot better, as it looks like the particles spawn from one place and they sort of just spread around and go upwards and the gravity starts affecting them. Pretty cool, but the position itself isn't the best. So actually I want to move these GPU particles 2D node. So let's go into move mode by pressing W. And we can position it to anywhere we like and kind of try to center it inside the chest like this. So if we go back to select mode by pressing Q and we emit it again, it's much more like the coins are coming from the chest. Maybe we can move it a bit upwards. Yeah, something like this. But to really sell the effect, we have to change the scale and the alpha property of these coins because it's really like abrupt how the whole animation or particle spawning ends. So we can close the spawn for now and instead go to display and start with scale. So we do have scale min and scale max, which gives you some control over the scale, but we don't want to randomize it. It's much better if we use a curve for this. So let's click on scale curve, new curve texture, click on the curve texture, click on the curve, and here we can modify how these coins will look like. So we can do something like this. The coins start out pretty small, something like 20% of their full scale. Then they pretty quickly reach their maximum size, like this. For the most time, they stay at their maximum, and then we can scale them all the way down when they disappear. So what this does, basically from left to right, is their lifetime. So 0 means 0% of their lifetime of that 1.5 seconds we have. And 1 means the end of that 1.5 seconds. So you can think of these values as percentages on both axes. The horizontal axis is the lifetime, and the vertical axis is the scale itself. So when we emit this now, you can see that it looks a bit better, although it's not perfect, but the coins start out pretty small and then they scale up. Maybe they don't even need to be this big. And we don't have to scale them all the way down. So maybe something like this. Yeah, it's good enough for me. But what really helps to sell this effect, if we do a similar curve for their alpha values. So they're transparent by default or at this part of their lifetime. So we can collapse the scale for now and go into color curves. And we can go into alpha curve and create a new curve texture for the alpha values. And this curve is empty by default, but we can create a new curve. And again, we have the same thing, but this time for the alpha value. So we can say that, okay, the coins will start out almost fully transparent and they pretty quickly become fully opaque. And also towards the end of their lifetime, we slowly but surely make them transparent again. So let's see how this looks like. See, it really helps to sell this effect. And I'm pretty happy with the results. Maybe they can be, again, it can take a bit longer for them to become fully opaque. Yeah, I kind of like it. Okay. You can spend a lot of time tweaking these particles, and that's not the point really of this whole course or this video, but it's part of the process. So we'll say that it's good enough for now. And we don't have to emit it by default. We'll do this in an animation. So let's do the animations next. We'll have two animations for the treasure chest. So let's select the animation player and let's bring up that animation pane at the bottom. So we'll have two animations. One of them will be the basic one or the base animation, which we'll call highlight. And the point of this animation is to sort of suggest to the player that you can click on this treasure. So what we'll do is we will pulsate this chest. Okay, so we can use a couple of tricks here, which most people, especially if you're newer to Godot, would do by code, but actually we have options for this in the editor to make our lives easier. So I'll zoom out just to see our timeline a bit better. And we can change the length of the animation to 2 seconds. And that's the magic button we want, autoplay on load. What this does, it gives this icon to the animation. And when you run the scene or when the animation player is active, it automatically starts playing this animation. Another cool thing we can set is setting the animation to loop. And for this, we use this icon here, animation looping. If you click on it, it becomes blue and the animation will loop. Okay, pretty cool. So now we can do something like go to 0 at the timeline, select the treasure chest, and under layout and transform, we can add a new keyframe to the scale property, right? So click on this key icon next to scale, create a reset track, and we can do something like maybe add a keyframe at 0.1, or let's change the snap to 0.05. So we can do something like 0.15, add a new keyframe, and add one at 0.3 seconds too. And change the middle one, this keyframe right here, from 1 to something like, let's make it subtle first. So something like 1.05. And you can see that if I play the animation, we do have this pulsation or this pulsing effect, but something's a bit off. First of all, for pixel art, it doesn't really seem that well that you kind of start to stretch it out, right? And the other problem is that the whole scaling happens from the top left corner. So let's fix that first. If we select the treasure chest and go to pivot offset, we can see that the pivot is set to 0, 0, which is the top left corner. But we know that this treasure chest is 40 by 40 pixels. So we know that the center of this would be 20, 20. And you can see that this little orange cross here moves from the top left corner to the center of the image, which is indicating that the pivot offset is there. So now if we start playing the animation, you can see what happens. It's no longer that little weird thing where we scale from the top left corner. It looks nice, but one more thing we can do is we can address this issue that the scale looks really bad for pixel art. So we have multiple options when we interpolate from one keyframe to another. The default one is called linear, right? But if we go to nearest, then this will be rounded instead. So what happens is if you take a look at it, It only changes when it has a new value, and it has this really cool pulsating effect, which I like. It's subtle, but it's visible enough to indicate to the player that something happens if you click on that chest. And I kind of like the pause between the pulses as well. 2 seconds, I think, works fine for this. So the cool thing about autoplay and looping is if we save this scene and run it to test it, you can see that the animation will automatically play. And since we have looping enabled, it will keep on playing and pulsating the chest. Pretty cool. So that's one animation we need to make. But we need to make another one when we actually open the chest, right? So go to animation, click on new, and let's call this animation open. Okay, so this one can be 2 seconds as well. And we need to do a bunch of things. First of all, we need to change the sprite or the texture this time for this texture rect to imitate the chest opening. So let's select the treasure chest, scroll all the way up and create a keyframe for the texture property. Create a reset track as well. And maybe we can insert a new keyframe at 0.2 and one at 0.4. And we can change these frames by clicking on the texture and loading first that slightly open one. And then for the final one, we can load from the art folder again that fully open one. So now we have something like this, right? Looks like the chest is opening. Awesome. And to sell this effect a bit more, we can also do something like this. At 0.2, when we have the frame change for the slightly opened one, we can select the GPU particles. And what's really cool about Godot's animation player system is that we can keyframe pretty much any properties. So we have the emitting property for the particles 2D, and we can just keyframe this one and say that on this frame it should be on. And what this does is, you guessed it, it spawns the particles. So if we play the animation from the beginning, it will look like this. Awesome, right? So that's pretty much it for now, but we have to come back to this animation later. Let's save this with Ctrl S. And before we jump into coding the treasure and replacing the placeholder code, one thing we need to be very aware of is that we want to be able to click on the chest, right? Because the reason why we play this highlight animation at all is because we want the player to click on the chest. But if you remember, that's a bit tricky with UI nodes because you have to remember the mouse filter settings. So we have to make sure that if we select the treasure chest, we can close the animation pane for now. And if we select the treasure chest, we have this group here, group of settings for controls called mouse. And you can set that the filtering in the case of this texture rect is set to pass, which means that this treasure chest won't pick up that click by default, so we have to change it to stop. This way we can detect the clicks on the treasure chest. And just to make sure, we can check the backgrounds. If they're set to ignore, so we can click on them, but we copy this over, or pass works fine too. Also for the treasure one, because for control nodes by now, you should know that this is set to stop by default, but this we changed when we did the placeholder version of this room. Okay, so the mouse filter settings are all fine. Awesome. Now we can actually do the code for the treasure room next. So before we jump into coding the treasure room, we have a slight little change we need to make. So let's press Ctrl+O and search for events.gd. And if you take a look at this one, we already have a signal called treasure room exited. And that's perfectly fine, but we need to change this a little bit. Why? Think about the flow of logic we need to apply here. We said that we don't want the treasure room itself to handle all the relic management because we already implemented the BattleReward scene. We just tweaked it a little bit so it supports relics now as well. So what we want to do is, if you click on a treasure room, you go to a treasure room, click on the chest, the animation plays, and then you go back to the run, and the run will instantiate for us a new BattleReward scene, right? And we pass on the relic we found from the chest, and adding the relic to the player and all that stuff will be handled by the BattleReward itself, pretty much. So to do this, we have to add a new parameter to this signal. So when we exit a treasure room, we have to let the run know which relic we found. So then the run can instantiate a BattleReward where you can click on that relic, right? So to establish this line of communication, what we do is we add a parameter for the relic we found in the treasure room. Pretty simple, right? So we can save this with Control S. So if we go back to the treasure scene, there are two things left to do. First of all, we want to have access to the animation player so we can play the open animation when we click on the chest. So let's right click on this and access it as a scene unique name. We can close the animation pane for now. And also one thing we need to do is to take the treasures script we currently have, its placeholder code. But what we want to do is we connect the treasure chests GUI input signal, right? So we can detect when we click on it. So double click GUI input and connect it to our treasure.gd, like so. So now our code is ready to go. Let's see how we can do this treasure room. So first of all, we no longer have a button which we can exit the room with. So we can delete this code for now. And first of all, we'll provide a custom class name like we usually do. This time we call it treasure. Then we'll have 3 export variables. 2 of them are dependencies that we need to provide from the run. One of those is the relic handler, which we need to use, and another one is the character stats resource. But the third one, the treasure relic pool, is again an array of relics, and it serves a similar purpose to what we had in the shops, right? Again, this is just to give the designers, or if you're the designer for you, the flexibility to have a different pool of available relics as treasure rewards and as possible relics with which you can buy in the shop, right? So again, we have to explicitly say that, okay, this is the list of relics you can get when you enter a treasure room like this. Then we have an onReady variable for the animation player and the member variable for the relic we found when we open the chest. Then we just need a couple of relatively easy methods. One of them is to generate the relic which this treasure chest will hold, right? So what we do is we take the available relics, which comes from the treasure relic pool, that array of relics we have as an export variable, and filter through them. The filtering is the same that we had for the shop ones. So first of all, we'll see if it can appear as a reward for that given character. So again, the warrior can't have wizard relics, right? And second, we also have to check if we already have that relic in the relic handler, because we can't have the same relic twice. After filtering through the pool of available relics, the only thing we need to do is to pick a random one, right? So we pick one and we store it in the found relic member variable. Then we have a method called onTreasureOpened, and what we do is just emit that signal, right? That event bus signal that the treasure room can be exited now. Mind you that we have to pass the found relic as a parameter because we updated that signal. And I also included a comment here saying that, okay, this will be called from the animation player at the very end of the open animation. This is just a note to us, the developers, that this is not a superfluous method. This will be called. We'll just use a call method track in an animation, right? So it's easier to find or debug when something goes wrong. And the last thing we need to do is to handle when we click on the chest. So the first thing we do is we see if the animation player's current animation is equal to open, because that means that we already played that open animation. So if the user starts spam clicking the treasure chest, we don't restart that animation over and over again. This is a safety check to make sure that we can only start playing that animation once. But if we can start it and the event is a left mouse button click, then we call the animation player's play method and play the open animation instead of the auto playing highlighting one, right? And that's it. That's all we really need in the treasure chest. It's pretty simple, like 30 lines of code. And we can save this with Control S. But before we can hook this up, let's not forget to A, set those export variables so we know what the treasure relic pool is, and B, we do have to call that method from the animation. Okay, so 2 things we still need to do. Let's go back to 2D view and start with the export variables. So let's select our treasure node here, go back to the inspector tab, and you can see that the treasure relic pool is pretty empty now. So click on the array, and let's say we can only get 3 relics this way. Namely, we can get coupons because it's a shop-only relic, and we can get healing potion because it's a starter relic. So for these treasures, we can get explosive barrel, mana potion, or reinforced armor. Okay, that's done. We can save it with Control S. And if we go back to the animation player, we have our open animation here. And we can go all the way to 2 seconds, the very end of the animation, add a new track, and we'll add a call method track this time. We'll use the treasure node because that's the node that has the method we want to call here. Click on OK. Right click, insert a key, and we'll call on treasure opened, right? Click on open, and you'll see that we'll have the function call here, which again will be used to emit the signal that the treasure room was exited and we found a relic. Awesome. So we can save this with Control S. And we need to hook this up because right now we have this generate relic method, but it's not called anywhere. And we also need to establish that connection between the run, the treasure, and then moving on to a BattleReward where you can actually pick up that relic. So that's the final piece of the puzzle here. Hooking this up shouldn't be too confusing because we did stuff like this in the past. So let's press Ctrl+Alt+O and search for run.gd. And the first thing we need to look at is this setup event connections method. Okay, this is where we do all that stuff. So for now, we have this events.treasureroom.exited.connect show map. And this won't do it anymore because when we exit the treasure room, we don't want to see the map yet. We want our own custom logic to create like an in-between step where we actually have a battle reward scene, right? Where we have that relic reward, which we can click on. So let's change this and we'll have our own callback method called onTreasureRoomExited. Now if we scroll all the way down to onMapExited, this is the method where we decide what happens when we enter a specific type of room, right? And for the treasure one, we have this placeholder called change view treasure scene. Well, entering the treasure room is not just changing the view to the treasure scene anymore either, because we want to inject dependencies, right? We said that it has 2 dependencies, the character stats and the relic handler. So again, we have to provide our own custom logic here. And what we do instead is we'll have our own custom function called onTreasureRoomEntered. So now we have 2 errors. One is that we don't have this onTreasureRoomEntered, and the other one is that we don't have this onTreasureRoomExited. So the last piece of the puzzle is to provide those 2 callback methods, and then we are good to go. So maybe we can do this somewhere in between the campfire and the battle room, just to mirror that order we have on the onMapExited right here, right? So we have the battle room, treasure, campfire, shop, and then the boss. So maybe it's logical to keep the same order here, so we can provide those 2 callback methods between the battle room entered and the campfire entered. And both of those are pretty simple too, actually. So for the treasure room entered, what we do is we indeed change the view to the treasure scene, but also save that instance so we can inject the dependencies, the relic handler and the character stats. After injecting those dependencies, we shouldn't forget calling that generate relic method, which picks one random relic from the available treasure relic pool. And that's basically it. But when we exit the treasure room, let's not forget that we have the relic we found as a parameter. So what we can do is we can change the view to a battle reward scene instead this time. We inject the proper dependencies, the run stats, character stats, and the relic handler, and call that brand new method we just created called add relic reward. And everything else will be handled by the battle reward. So I think that's a pretty elegant solution because we still see the same reward scene we see at the end of the battles, but we can have that nice little treasure opening animation, and we don't really have to worry about re-implementing anything we already did for the battle reward. So that's it, and if I haven't forgot anything, then we should be good to go. So let's save our run.gd file and start a new run and see what happens. So we can play the combat as usually. I still have that debugging 700 gold, and also that 60 damage strike card, which makes it pretty easy to reach the treasures. You can go into a shop, buy the coupons, buy some cards, maybe. And we can move on to the next one. And after a while, I arrived at my treasure room destination here. So if I click on it, I go into this treasure room, the chest is pulsating, I can still look at my relics, look at my deck if I want to. The chest is still pulsating, and if I click on it, the animation plays. And after the animation plays, we immediately are greeted with this battle rewards scene. And I have my little armor as the reward I rolled. So if I click on it, you can see it disappears. And the reinforced armor relic indeed gets added to my relic handler. And if I go into battle, it will work as expected. So if I end my turn here, I gain the 3 block from the relic. Awesome. So that's it for this video, and I'll see you in the next one. Bye bye.